Today we're going to solve a problem on distance and displacement. So the problem goes like this. John walks with an average velocity of 1.32 meters per second eastward. So I'm going to make that eastward right there. And first of all, what does 1.32 meters per second mean? That means that an object is traveling 1.32 meters each and every second. And that goes on for 23 minutes, because it says if it takes him 23 minutes to walk to the store, what is his displacement and what is his distance? So whenever I solve a problem, I like to include 5 things. Number 1, I like to draw a simple physics diagram. Number 2, I like to provide given and unknown information in the proper place on the diagram. Just don't go ahead and list it. That doesn't help you solve the problem. Write it on the diagram where it belongs. Number 3, an original equation. So that's an equation that another scientist would, recognize that form. Number 4, you want to substitute in with correct units into your equation. And number 5, that's where you actually want to do the math and solve. You want an answer with correct units and a box around your answer. So that's how I'm going to present my solutions, and that's a good best practice. I would do it that way also if I were you. All right, so let's start step number 1. We're going to draw a diagram. So I'm going to represent John as a dot, and that dot is referred to as a point mass. So we're going to take John and we're going to kind of squash him down to an itsy bitsy little point. And that just makes the physics a little bit easier. So here's John. He's a dot. I'll make him a big dot, but he's a dot. And I'm going to draw a straight line with an arrow. So John is traveling in that direction, in a straight line. All right? This is sometimes called linear motion or motion in one dimension. All right, so what's John's, doesn't say his initial speed. He gives us an average velocity. So what I'm going to do, because he kind of walks the same velocity along the entire length, I'm going to write it like this. I'm going to write a V with a bar over it. That means average velocity. And his average velocity is 1.32 meters per second. He does this for 23 minutes. So time equals 23 minutes. And then my unknown, I am looking for the distance or displacement. All right, I'm looking for the length from here to here. So there's my simple physics diagram, and there's my given and my unknown information. So the next step here is to write down a formula. So the formula I'm going to use here is average velocity equals displacement over time. That's the formula I'm going to use. I'm looking for the displacement. All right, so I definitely, when I pick a formula, I definitely need, in this case, displacement to be present there. And then the rest of the formula, I need to have the information for it. So do I have the information for average velocity? I do. Do I have the information for time? I do. But time is in minutes. This formula takes seconds. So I've got to convert 23 minutes into seconds. So the way I'm going to do that is I'm going to actually use dimensional analysis. I don't like it when, all of a sudden, people just multiply or divide. Right? I need to know why. Why did you do that? So we're going to use dimensional analysis. So I'm going to write down what I'm given, 23 minutes. And I'm going to make a fraction out of this. So I'm going to put it over 1. Now it's in a form that I can use. I've got minutes on top, and I want to get rid of minutes. So what I'm going to do here is I'm going to multiply by a conversion factor. That's a conversion factor. So if I've got minutes on top and I want to get rid of minutes, what I'm going to do is I need minutes on the bottom. That way my minutes cancel out. And I know that 1 minute equals 60 seconds. And now my minutes, not my numbers, but my units cancel out. And I am in seconds. So 23 times 60 is going to equal 1,380 seconds. 1,380 seconds. Now I'm ready to substitute this into my formula. So I know the average velocity, 1.32 meters per second. I'm looking for the displacement, and then my time is 1,380 seconds. Now I can go ahead and solve. So that was part 4, substitute in correct numbers and units into my formula. And now I'm looking for x. So mathematically, we want to get x all by itself. So how do I do that? Well, what I got to do is I got to multiply both sides by 1,380. And when I do that, this cancels out, and I'm left with 1,380 times 132. And when I do that, I get 1821.6 meters. All right? And we're not quite done yet, because this is a displacement. So what I've done so far is I've found the magnitude. So I'm halfway there. But a displacement has a magnitude and a direction. So the direction, originally he was traveling east. So I'm going to go ahead, I'm going to put a comma, and then I'm going to write east. And I'm going to put a box around my answer. All right? So here we round it off to the tenths. If you're using significant digits, then this answer would actually be 1,800. You'd round it off to 2 significant digits. So it'd be 1,800 meters east. But if you just round off to the tenths, that is what you're going to get. Now, part B is, what's the distance? Well, it turns out, distance is the total length traveled. It turns out that the distance and displacement, or at least the magnitude of the displacement, going to be the same number in this problem. Going to be the same number. So my distance is actually going to be 1821.6 meters. But distance is scalar. Remember that, distance is scalar. So it does not have any direction associated with it. So I just write the number or the magnitude, and I am done. And that's it for this problem.